Today we will discuss about the chemical properties of monosaccharide. As we know that what are the monosaccharide? Monosaccharide are simple units of the carbohydrate in which only single sugar molecules are present, hence known as monosaccharide. Now, what are the chemical properties of monosaccharide? There are different reactions due to different groups. First one is reaction due to carbonyl group and second one is reaction due to hydroxyl group, because there are two types of groups are present. One is carbonyl group and second one is hydroxyl group. Now first we will discuss about the reaction due to carbonyl group, in which first is reduction reaction. When glucose is reduced with sodium amalgam, NaHG is known as sodium amalgam, then forms the sorbitol, while fructose forms the mixture of sorbitol and mannitol. Now the reaction will be, this is the structure of glucose. This is glucose structure. Now when reacts with sodium amalgam, this is known as sodium amalgam, then undergo the reduction and forms sorbitol. This is sorbitol. When fructose, the structure of fructose is this is fructose structure. When this react with sodium amalgam, then it also undergo reduction and forms the mixture of sorbitol or mannitol. Now second reaction. Second reaction is also reduction, in which we will discuss about the aldoses and ketoses in different types of reaction. First we will discuss about the aldoses. In presence of mild oxidizing agent like alkaline copper salt, sodium hypobromide or silver oxide, then forms a monobasic acid having the same number of carbon atoms. First we will discuss about aldoses, then glucose. This is Ag2O or sodium hypobromide, undergo mild oxidation, then forms gluconic acid. This is the structure of gluconic acid. While in presence of a strong oxidizing agent like nitric acid, then forms a dicarboxylic acid, that is saccharic acid. The reaction will be, in the presence of nitric acid there is a strong oxidation, then forms saccharic acid. This is the structure of saccharic acid. Now next reaction is of ketoses. As we know that fructose is the main example of ketoses. In presence of a strong oxidizing agent like HGO or Ag2O, forms the mixture of monocarboxylic acid. And in presence of a strong oxidizing agent like HNO3, glucose form trihydroxyglutonic acid, tartaric acid and glycolic acid. So fructose forms these types of acid, and the reaction will be, this is the structure of fructose in presence of HGO or Ag2O, then forms different types of acids, while in the presence of strong oxidizing agent it undergoes strong oxidation, hence forms different acids. This is trihydroxy glutonic acid plus tartaric acid plus glycolic acid. Now these reactions shows their oxidation and reduction properties. Now what is the reducing nature of monosaccharide? When we react with Tollens reagent, when glucose treated with Tollens reagent or silver mirror is obtained, or the wall of test tube and also gluconic acid is obtained. In the same way, when ketoses, that means is fructose treated with Tollens reagent, then trihydroxybutyric acid and silver mirror glyconic acid is formed, and the reaction will be, this is the fructose structure. When reacts with Ag2O, then forms CH2OH, COOH. This is known as gluconic acid plus COH, CHOH whole twice, and CH2OH. This is trihydroxybutyric acid plus 2 molecules of silver. Now second reaction is with Fehling solution. When glucose treated with Fehling solution, then red precipitate and gluconic acid is obtained. In the same way, when fructose treated with Fehling solution, then red precipitate of cuprous oxide, gluconic acid and trihydroxybutyric acid is formed. First we will show the reaction of glucose. This is the structure of glucose. It reacts with cuprous oxide, then forms this is gluconic acid plus red PPT of cuprous oxide. Now this is glucose. Now we will discuss about the reaction of fructose. This is the structure of fructose. When this reacts with CO, then forms CH2OH, COOH, and this is the trihydroxybutyric acid structure. Plus red precipitate of cuprous oxide. Now we will discuss about the action of hydrogen cyanide. When glucose and fructose treated with HCN, then glucose cyanohydrin and fructose cyanohydrine is obtained respectively, which on hydrolysis corresponding acid forms. If these acid reduced with hydrogen iodide and red phosphorus, then forms N-heptonic acid or 2-methyl hexanoic acid, and the reaction will be, this is glucose reaction. When this react with HCN, then this oxygen is out with this hydrogen, and this cyanohydrin is attached with this CH group. This forms, here is OH and here is CN. This is glucose cyanohydrin. Again react with HCN, then forms COOH, CHOH whole 5 and CH2OH. When again react with red phosphorus and hydrogen iodide, then forms COH, CH2 whole 5, CH3, that is N-heptanoic acid. Now when fructose react with HCN, then forms CH2OH, COH, CN, CHOH का whole thrice, CH2OH, this is fructose cyanohydrin. When it's react with one water molecule, then forms CHOH का whole thrice and CS2OH. It again react with red phosphorus or hydrogen iodide, then forms CS2 का whole thrice and CS3. This is 2-methyl hexanoic acid. These are the reaction of ketosis and hexosis with HCN. Now we will discuss about the condensation with hydroxyl amine. When glucose or fructose treated with hydroxyl amine, then glucoxine and fructosine is obtained, and the reaction will be, when glucose react with hydroxyl amine, the formula is H2 and OH. Then this oxygen and this hydrogen molecule will form a water molecule, and it will come out and then forms CH double bond and OH. The remaining will be same, and the name will be glucoxine. And now when react with fructose, then this oxygen and this hydrogen molecule will form a water molecule and comes out and then forms and the remaining will be same, and the name will be fructosine. This is the condensation reaction of monosaccharide, all ketoses and hexoses. Now condensation with hydrazine. When glucose or fructose condense with hydrazine, the formula will be NH2NH2, and then glucose hydrazine or fructose hydrazine are formed, and the reaction will be NH2 and this hydrogen and this oxygen will form a water molecule, and it will come out, then CH double bond and dot NH2, and the remaining will be same structure, and the name of this structure is glucose hydrazone. And when we discuss about the fructose, when it reacts with hydrazine, then this oxygen and this hydrogen forms a water molecule and comes out, and the form CH2H, C double bond N, NH2, and the remaining part of the structure will be same. And the name of the product is fructose hydrazone. This is all about the condensation with hydrazine. Now condensation with phenyl hydrazine. When glucose or fructose treated with phenyl hydrazine, then glucose phenyl hydrazine or fructose phenyl hydrazine is obtained, and the reaction will be this is phenyl hydrazine formula, and then this hydrogen and this oxygen will react and forms one water molecule and comes out, and then the product will be glucose phenyl hydrazone. And when it reacts with fructose, then again one water molecule will come out and then forms fructose phenyl hydrazone. Now when condensation with semi-carbazide, then glucose forms glucose semi-carbazone and fructose forms fructose semi-carbazone, and the reaction will be this is the formula of semi-carbazide, and when it reacts with glucose, then one water molecule will also come out and forms glucose semi-carbazone. And when it reacts with fructose, then again one water molecule will come out and then forms fructose semi-carbazone. Now reaction due to hydroxy group. In this, first we will discuss about the action of PCl5. When glucose or fructose react with PCl5, then forms pentachloroglucose or pentachlorofructose, and the reaction will be when glucose react with 5 molecules of PCl5, then 5 POCl3 and 5 HCl. Because here is 4 molecules and here is 1 molecule, then the product will be CHO CHCl whole 4 CS2Cl, that is pentachloroglucose. Same when reacts with fructose, five POCl3 and 5 HCl will comes out, and the product will be CS2Cl, C double bond O, CHCl का whole thrice and CS2Cl. That means the chlorofructose. This is the reaction with PCl5. Now reaction with thionyl chloride. When glucose or fructose treated with thionyl chloride, then pentachloroglucose and pentachlorofructose is obtained, and the reaction will be the thionyl chloride, then 5SO2 molecule and 5HCl molecule will come out, and the product will be pentachloroglucose. And in same manner, when it reacts with fructose, then also 5 molecules of SO2 and 5 molecules of HCl will come out, and the product will be formed is pentachlorofructose. Now third reaction is methylation. When glucose or fructose treated with dimethyl sulfonate, then forms pentamethyl glucose or pentamethyl fructose. The reaction will be, this is the formula of dimethyl sulfonate. When it reacts with glucose, this is the glucose structure, this is the dimethyl sulfonate, then forms pentamethyl glucose. In the same manner, when it reacts with fructose, then forms pentamethyl fructose. This is fructose, this is dimethyl sulfonate, then forms in every hydrogen where is attached, then by the replacement of this hydrogen, this methyl group is attached in place of hydrogen, and then forms pentamethyl fructose. Now next reaction will be esterification. When glucose or fructose treated with acetyl chloride, acetic acid or acetic anhydride, then forms glucose pentaacetate or fructose pentaacetate, and the reaction will be, this is the glucose structure. When it reacts with acetyl chloride, CH3COCl, 5 molecules of acetyl chloride, then 5 molecules of hydrogen chloride comes out, and then forms CHO, CHO, CO, CH3 का whole 4, CH2O, CO, CH3. This is glucose pentaacetate. When it reacts with acetic acid, this is glucose structure. It reacts with 5 molecules of acetic acid, then forms glucose pentaacetate. When this acetyl chloride is react with fructose, then 5 molecules of HCl will come out, and then forms fructose pentaacetate. Now when fructose react with acetic acid, CH2OH, C double bond O, CHOH whole thrice, CH2OH, this is fructose. When it reacts with 5 molecules CH3COOH, then 5 molecules of H2O will come out, and then forms CH2O, COCH3, C double bond O, CHO, CO, CH3 का whole thrice, CH2O, CO, CH3. This is fructose pentaacetate. This is acetic acid. This is all about the chemical properties of monosaccharides.